Let's remember that the set of integers includes all of the positive whole numbers to the right or above the origin, all of the negative whole numbers to the left or below the origin, and of course, the all-important origin itself, 0. That is the set of integers. When we pop those bubbles, we reveal all of the rational numbers, everything in between. All of the stuff now gets revealed. So let's take a look at some of those. If we split right between 0 and 1, what will we label right here? Well, it's in two parts. They are each 1/2. If we split between 1 and the 2, we have 3/2, or 1 1/2. Split between the 2 and the 3, what do we get? You can write it as an improper fraction, 5/2, or 2 1/2. Now, just like integers have their opposites, rational numbers also have their opposites. If we go right between the -1 and the 0, we have a -1/2. If we go right between the -1 and the -2, we get -3/2, or I can write it as -1 1/2. What's this going to be? If it's improper, it's -5/2. If it's a mixed number, it's -2 1/2. Now I'm only showing you the halves. Right here, just barely to the side, there's thousands of numbers. I could write that as 1/1000 or 2/1000. Right on the other side of the 0, it would be -1/1000, or whatever tiny fraction you would have. Every rational number has an opposite also. Now just a note over here. The definition that will be more important in future years is you define the set of rational numbers by any number that can be written as a over b when b is not 0. You can never have a 0 on the bottom of a fraction. But you can take any two other numbers in the universe, including 0 on the top, just not on the bottom, and when you divide two numbers by each other, you get rational numbers.